1.4 Modulus function. The absolute value of x, or the modulus of x, denoted by x in between two straight lines, is defined by modulus x is equal to x if x is greater than 0, modulus x is equal to 0 if x is equal to 0, and modulus x equal to negative x if x is less than 0. Hence, when x is negative 5, modulus x is equal to 5. When x is 5, modulus x is equal to 5. From the definition of absolute values, we have the following property. If modulus x is equal to k, where k is greater or equal to 0, then x is equal to k or x is equal to negative k. Let's look at the example 1.4.1. Solve each of the following equations. Question 1. Modulus 3x minus 7 is equal to 13. Modulus value will give us a positive and a negative value. So we have 3x minus 7 equal to 13, and the other one is 3x minus 7 equal to negative 13. For the first one, 3x is equal to 13 plus 7, which is 20, and x will be 20 over 3. For the second one, we have 3x is equal to negative 13 plus 7, which is negative 6. X will be negative 6 divided by 3, which is negative 2. Second one, modulus x squared minus 3 equal to 6. The same thing. The first one we have x squared minus 3 equal to 6. And the second equation we will have x squared minus 3 equal to negative 6. Let's solve for the first one. We have x squared equal to 6 plus 3, which is 9. X will be square root of 9. We have 3 and negative 3. For the second one, we have x squared equal to negative 6 plus 3, which is a negative 3. X squared will always give us a positive value. Therefore, this question is invalid. For the third one, we have modulus 3x squared minus 5x equal to 7x. For the first equation, we have 3x squared minus 5x equal to positive 7x. And the second equation, we have 3x squared minus 5x equal to negative 7x. Let's solve the first equation. This is a quadratic equation, so let's bring all the terms to one side. We have 3x squared minus 5x minus 7x equal to 0. Simplify it, we have 3x squared minus 12x equal to 0. Factorize the equation, we have 3x bracket x minus 4 equal to 0. 3x equal to 0 and x minus 4 equals to 0. So 3x is equal to 0, meaning x is equal to 0. And the second one, we have x equal to 4. For the second equation, 3x squared minus 5x plus 7x equal to 0. Simplify it, we have 3x squared plus 2x equal to 0. Factorize it, we can take out the common terms, which is the x. We left with 3x plus 2 equal to 0. Therefore, we have x equal to 0. 3x plus 2 equal to 0. So 3x will be negative 2. X will be negative 2 over 3. Example 1.4.2. Sketch the graph of each of the following absolute value functions. The first one, we are going to sketch h of x, which is equal to modulus 1 minus 2x. For the domain, x is between negative 1 and 4. What we can do is, we draw a normal graph for hx, which is the graph without a modulus. let's get some value to sketch our graph. -1, 0, and 4. When x is -1, we have 1 plus 2, which is 3. When x is a 0, we have 1 minus 0, so we have 1. When x is a 4, hx will be 1 minus 8, which is -7. Then we sketch the graph. When x is -1, hx is 3. When x is 0, hx is 1. When x is 4, hx is 7. So this is how the graph of hx without a modulus should look like. Since our hx is a modulus function, all the value in the negative should become positive. So when x equal to 4, the hx should equal to positive 7. So the graph should actually look like this. Touching the x-axis, then flip it up. So this graph is hx equal to modulus 1 minus 2x. State the corresponding range of the value of hx. When x is from -1 until 4, our hx, which is our y value, will be between 0, because the smallest value is a 0, and the greatest number is a 7. For the second one, we are going to sketch k of x, which is equal to modulus 2x minus 3 for the same domain, which is x is between -1 and 4. We'll be doing the same thing. We're going to sketch the function kx without modulus. -1, 0, and 4. When x is -1, kx will be -2 minus 3, which is -5. When x is a 0, we have kx equal to -3. When x is 4, we have 8 minus 3, which is 5. Let's sketch the graph. We need to have 5 and -5. Let's plot the graph. When x is -1, kx equal to -5. When x is 0, kx is -3. When x is a 4, kx equal to 5. This is a graph where kx without the modulus. And again, since our kx is a modulus function, so all the negative values should become positive. When x is -1, our kx should equal to 5. When x equal to 0, our kx should be 3. and this will be the point. Let's join all the points together, touching the x-axis. So the blue line will be our graph for k of x with modulus 2x minus 3. And the range for kx will be kx is between 0 and 5, because 0 is the smallest kx value and the biggest value is 5 for the range of x between -1 and 4. Example 1.4.3. Sketch the graph of g of x equal to modulus x squared plus x minus 6. First, we need to find the x-intercepts and y-intercept of the graph g of x without modulus. So let's say our g of x is equal to x squared plus x minus 6. When x equal to 0, g0 equal to -6. So this is our y-intercept. When gx is equal to 0, 0 equal to x squared plus x minus 6. Factorize the equation. X squared is separated into x and x. 6 is 2 and 3. Here we have 2x. Here we have 3x. In order to get a positive x, minus 2 plus 3. We have a positive x. Minus 2x plus 3x. And lastly, we also need to double check negative and positive. We should get a negative, correct? Therefore, x minus 2 is equal to 0. X plus 3 is equal to 0. X will be 2. X will be -3. These two answer is our x-intercept. Then we sketch the graph of gx. Since we have a positive x squared, our graph gx is a smiling curve. Where it cut through -3 and 2 for our x-intercept and -6 for our y-intercept. And now, because our gx is a modular graph, so all the negative value become positive. Instead of having a -6 as our y-intercept, it will become +6. So this part remain, this part also remain. This part we have to flip it over. The blue graph is our final graph. Gx equal to modulus x squared plus x minus 6. For the next section, we will discuss more questions on modulus function. You may try the questions and see how much you understand about this topic. In the next video, a detailed solution will be given. Good luck in trying the questions. See you again in the next video.